Chloe, what are you doing with the sock? Oliver!
You know, when I was single, my dogs never got my socks. I always kept them away. But my girlfriend likes to borrow my socks and then leave them everywhere. Anyway, welcome back to Coding with Dogs. My name is Craig. I'm a senior software engineer with a decade of experience working for Fortune 500 companies. And now it's time to really start getting into the details of how to use React Testing Library. Now, in the last video, we went through the whole setup process for the project. If you didn't watch it, I encourage you to go back just to get that nice foundation in. And this lesson is going to focus on some of the really good features RTL has to offer, specifically how to query for elements on the page, one of the essential tasks for any set of UI tests. In RTL, when we want to grab something on the page, it's called a query. Now, as I said before, React Testing Library really tries to restrict you to only interacting with your components the same way your users will. Because of that, it only allows you to select elements based on items that are visible. Either visible to the user, like looking at the page with their eyes, or visible to a screen reader via various accessibility options. Now, accessibility is a good practice to begin with, although I'll fully admit from personal experience, it's the easiest thing to overlook. However, RTL's tight integration with accessibility features in its selectors just further encourages this really good practice. Now, what you're seeing here on this slide is a list of all the different selectors RTL can query by. You can query by text, accessibility role, label text, placeholder text, display value, alt text, title, and the, in case of emergency escape hatch, test ID. These 8 options cover an incredibly wide range of scenarios, allowing you to grab elements off the page and run assertions on them. Now, we're going to dive into the code and go through examples of how to use each one of these, but I am going to emphasize that, at least in my experience, the overwhelming majority of the time, the first 3 on this list, text, role, and label text, are the ones I find myself using almost across the board. So, this is where we left off in the previous lesson, with our simple Hello World test. Now, we're going to build upon this to demonstrate all the different selectors that are available in RTL. So, first and foremost, I'm going to grab something I've written ahead of time. It's just a slightly more robust version of our Hello World component, with a whole bunch of elements here to allow us to demonstrate the different forms of selectors that are available. And so instead of this Hello World JSX here, we are just going to reference our component as JSX, and now the whole thing will appear on the screen. Now, from our previous lesson, we have this statement right here, where we're using a getByText query. This query is using a text selector. Specifically, it's looking to see if the string Hello World appears anywhere in the page, and if so, it is grabbing that element. Now, I'll point out this only works if it appears a single time. We'll talk more about that later in the lesson. Now, text is great, but there are a wide range, as I've said, of additional selectors that are available to us. And let's start going through them and seeing what they are. So the first big one that I want to cover is getByRole. In this case, we're talking about accessibility roles. So these are the things that, if you're not really familiar with accessibility, the HTML role attribute is a part of the HTML specification. It defines a series of roles that indicate to screen readers and other accessibility tools what an element on the page actually is. This way, folks who don't have the ability to see, either partially or completely, can still interact with a page and understand what is there. So a common one, or the one I'm using as an example right here, is progress bar. It is very often to have a progress bar on your page, And if you slap role progress bar, which is part of the accessibility spec, then any screen reader will be able to know what it is and relay that to the user. And if I actually look by progress bar using get by role, I am able to successfully grab and return that element. And so this works for any accessibility role. And by the way, not all accessibility roles have to be explicitly added to elements. There are a wide range of elements that have implicit accessibility roles, and we'll start getting it. We'll probably use some of them in a later lesson here. Now, the third one I want to get into, and the third one of that top three that I mentioned, is get by label text. So get by label text is intended for input fields and selects. So, as some of you may know, an input field can have a label element. Now, you don't have to use an HTML label element for the input field. And you certainly don't have to link the ID with the for attribute in the label. You can do anything that you want. However, doing it this way is a part of the HTML spec. It's a requirement of the 508 accessibility spec. And it's a really good practice because now we can use the link between the visible label and the input field as our selector. So, for get by label text, I can say get by the text field, which is the label text, and what it's actually going to do is it's going to query that this text exists as part of a label, and then it will grab the input field. And it's able to do this because in React it's called HTML4. This is compiled into simply for in the actual HTML. But for has a value that has to correspond with the ID on the input field. This is part of the HTML spec, and RTL uses it to give us a nice and easy way to grab an input field based on the associated label text. And by the way, it's not just the input element. This works for all form controls. For example, if I were to throw in the select field here, it'll still work. So those are the top three that are used most often, but there are a wide range of additional ones that I want to get into. So, for example, we have get by placeholder text. Now, a lot of input fields have a placeholder value, and this is something, again, that's visible to the user. And so we are able to query based on that placeholder text to pull back the input field. I keep turning on a breakpoint for some reason. We also have display value. Now, get by display value, this is a really key thing. So for this select component right here, the value of the select is first. But what is visible to the user is not first. This is a value that is internal to the application. What would be visible to the user is first option. And so get by display value allows us to query by the visible option in this select component. And it's not just used for select components, it's used for any form of form control to select by its display value. Now at this point, we're going to start getting into some of the less obvious options, but still extremely valuable. So our next one is get by alt text. Now when you have an image tag, you have the option to add alt text. Now again, you could choose to skip this, but it's part of the accessibility spec. It's a really good practice to always have an alt text that simply says what the image is. Screen readers, for example, will read this. Or if you're unable to load the image, it'll show this text on the screen. So again, it still falls into the category of things that are either visible or accessible to the end user that RTL focuses on. And so you can actually select this image tag by its alt text. See, we can still successfully grab it right there. Another option is get by title. So the title attribute is a tooltip. So it's where you can hover over an element and then a tooltip will appear with additional information. So this actually gives you the ability, now you could do a get by text on the visible text here, but not every element with a title with a tooltip will necessarily have visible text. And so this allows you to do a selection by that tooltip text and pull back the element that it's on. Now, all of these that I've covered so far, as I've said several times, all fall under the category of things that are either visible or accessible to the end user. However, there is another option. That option is Test ID. Now, it is strongly recommended to always stick with one of these selectors. It keeps you focused on, again, what is accessible to the end user rather than an implementation detail. However, there are always edge cases. And so you always have the ability to put the attribute data.testID onto your component, or onto any element in the JSX. That's a very important detail, actually. This must go on an actual JSX element because RTL only queries by what ends up in the actual DOM. It does not query based on what is present in the React virtual DOM. That's a critical difference between RTL and Enzyme, where Enzyme would support a lot of pseudo selectors based on the actual React components in the virtual DOM. RTL does not do that. Anyway, putting this attribute, data test ID, on this element allows us to assign a unique test ID to this element. And then we can do get by test ID, random text, and this will grab this element and pull it out. Now there you have it. These are the 8 different selectors that React Testing Library supports. They are an incredibly powerful tool at your disposal. However, RTL supports a variety of types on top of these selectors. So let's go in depth onto what query types are. Well, she got another one. Great. Anyway, so RTL supports a variety of query types. A query type is just a modifier on the selection that occurs. You're still querying based on the selector, one of the selectors that we just covered. However, how that selection happens is what changes. So the first type, or the first type distinction you have to be aware of, is singular versus plural. Meaning, do you expect to find one element that matches that selector, or multiple elements that match that selector? By the same token, do you expect that element to absolutely always exist? Or is it optional? Is it just possible the element could exist? And lastly, the last type to be aware of is waiting for the UI to change. This is something that we're just going to touch on in this lesson, but it's going to be huge later on as we start getting into user interactivity. It's a very common scenario where you'll have to wait either for asynchronous behavior or state updates or whatever. And so RTL offers a query type that allows for not just looking for something on the screen, but waiting for a period of time in order to allow asynchronous behavior, state changes, etc. to occur. All right, so let's see some examples of how these query types actually work. So first, let's add something here. Now we have Hello Universe appearing twice on the page. Now if I try to grab this by text, don't know why I just rewrote that, the same way we did before, we're going to have a problem. First, I want to point out that RTL gives crazy detailed error messages, complete with context clues and a whole output of the DOM tree. It's great. But what it says is, found multiple elements with the text, Hello Universe. This is because get by text assumes that you are only going to find a single match. In a situation where you're going to find multiple matches, you're going to do get all by text. And we're also going to see one more problem. Get all by text returns an array of elements because it's looking for multiple items. The to be visible matcher expects to be run on a single element. And so a solution to this is just to do a toHaveLength call on the result. Now you could then iterate over them and call to be visible, but for the most part, in these scenarios, to be visible is just being used, like I said, to make it explicit that these are assertions rather than just selectors we forgot to delete. So we know that if get all by text returns any number of elements, that means that they are visible on the page. So that right there is the get all variant right here, which is designed to retrieve multiple elements from the page. But what if you have a scenario where an element may or may not exist? For example, where we're doing get by text foo. There is no text foo on the page. And sure enough, the test will fail because get by and get all by will throw an error if no matches are found. Fortunately, RTL offers a solution. Query by text. Any RTL query that begins with the word query expects an element that may or may not exist. And so in this case, to do an assertion that this is not here, we could simply say to be null, because that's what will happen. Query by text will return null if it doesn't exist. However, RTL's ESLint rules strongly encourage using one of the built-in matchers. So to be in the document is very similar to be visible, namely, to be visible confirms that it's both in the DOM tree and visible to the user. To be in the document just confirms that it's in the DOM tree. And so not to be in the document is the recommended way to test that something does not exist on the screen. And again, being able to test that something doesn't exist frequently comes up when it comes to conditional rendering. The last thing I'm going to cover here, and I'm going to cover it only very briefly, I'm going to go much more in depth on the use of this in a later lesson, is how to handle asynchronous behavior. So if you're waiting on an API call and the results to render, or you've made a state change, or all of these things, there can be a delay between the action occurring and the UI reflecting that the action occurred. It's a very common scenario. Now, RTL offers a function called waitFor, which can wrap around anything. It has a callback function that it wraps around and then it waits for this to be complete. However, you don't have to use this particular function very often. And the reason is that RTL offers a find-by variant of its selectors. Now, find-by returns a promise, so we're going to do an async await. And then just to make it obvious that we're doing this deliberately, we're going to throw to be visible on it. And what this means is it will attempt to find this text on the page, and it will wait for a predetermined timeout. And as long as it can find that element within that timeout, granting time for asynchronous behavior to occur, it will return it to you. And sure enough, it's there. Now, this is always visible. This is not a scenario where you would use find by text, but we'll go more in depth into when to use it again in a later lesson. All of these selectors, all of these types, everything comes together to create what I'm sure is a very eye-popping matrix right in front of you right now. Every single selector supports every single type. So you can do get all by role or find all by title or anything in between. Every single one of these all comes together, providing a very diverse, very robust range of options to select elements in the DOM in React Testing Library. Alright, we just went through a lot of different query operations that you can do in React Testing Library. Now, the great thing is RTL offers some really robust documentation on all of its features, including queries. So don't worry, you can just go online and look up all this information. I'll try and include some links in the description. Our next video is going to be focused on user interaction. Now that we know how to select these elements on the page, we're going to cover the tools that RTL offers in order to interact with those elements and then validate the changes those interactions lead to. So if you enjoyed your time with me today, feel free to wag your tail and hit the like and subscribe button, and I look forward to being with you all again next time.
And this is why I keep buying socks.